Hello, this is Mr. Kayakondo with explanatory video number 1. Okay, so on this video I'm gonna go over the half sheet here. This is 6L6R, I think, number 6 on your on the website. So this side here I'm gonna finish off as a video, and then this is the first part of it. Okay, so this is mainly about the first quadrant of the unit circle. That's important to memorize because that's the one that gets you all the other ones. If you know that one, you can derive all the other ones. So here is going more for the meanings of sine and cosine, why certain things are x and y coordinates, why there's a specific meaning to them. Okay, this is just the actual first quadrant, so these will make a lot more sense as we go along. So let's go ahead and get started. So here it says the trigonometric ratios of cosine, sine, and tangent has specific coordinate or slope meaning on the unit circle. Okay, and the unit circle of course has radius of 1 because that's exactly why it's called the unit circle. And then here is a nice little general any angle with a radius of 1, and this is of course touching the circle. So here of course we mark it as theta, and then we mark that as the y. Of course that's the y coordinate, and of course from here to here is the x coordinate. But then also we remember our trig ratios that we're going to label opposite, adjacent, and hypotenuse. Okay, and then we go ahead and actually write the definition of sine of theta, which is going to be opposite, which is y, over hypotenuse, which is r. So then you put this over 1, right? So you can cross multiply with no problem. So if you cross multiply, you get that. You get y equals r sine theta, and of course that's an equality, so y equals that. But for the unit circle, remember r is equal to 1, so the radius is 1. Therefore here you can substitute 1. So once you do that, you're gonna get y equals sine of theta. So that's why the y coordinate is equal to the sine of that of some angle theta. That's why that's their equivalent. Now here, let me just put the little cross multiplication sign just so that we know exactly why we got that, and then let me kind of add it here as well. 1 second. Okay, so from them, same with cosine, we write the trig definition for cosine, and then so cosine is equal to adjacent over hypotenuse. So this, and then over 1, cross multiply, you get that. And once again, for the unit circle, you have radius equals 1, so you can substitute for the r, so that you have this, x equals cosine of theta. So your x coordinate will be the cosine of that theta. Okay, now for the tangent, we have just opposite over adjacent, no over 1, because that's just the definition of it. Okay, now we have this y and x, as we have a y and x here, so we can substitute for the sine theta for y and the cosine theta for x, and that's exactly what we did here. Okay, so now also you can say the tangent of theta is equal to the sine of theta over the cosine of theta. And just go back to this point right here. I want to connect this, and this is familiar back to algebra 1, rise over run. Okay, this is the y, vertical, horizontal. So it is very much related to this idea that that's going to give you the slope of the radius. So the rise over run will give you the slope of the radius, and that's the definition for the tangent of theta. But also, when you have something like this can also be rewritten as sine theta over 1 multiplied by 1 over cosine theta, because if you do this multiplication, you get this back. And this is useful. Sometimes you'll see in the next, right here on the right side, is very useful. So actually, let's go ahead to the right side already. So on this side, I actually wanted you to make sure you write all this down. Now, this is, I think, a very, very direct way of showing you for all the different special thetas. So we have 0, and then which is 0 and 0. So degrees and radians are 0. When degrees is 30, radians is pi over 6. So that's the equivalent, 45, 60, 90. Right now we're working with degrees because they're a little bit easier to work with. Radians cost a little bit more, and that's a little bit with the other half sheets that I have. Now I do want you to pause the video to actually write all these down so that you have a direct relationship with x and y and the meanings of the cosine and sine. Okay, so once you do that, for all these angles, it says here, find the sine theta, cosine theta, and tangent theta for each angle. Now, all these cosine of 0, and then for the 30, 45, for the 60, and the 90, they can be read off. These are easy. Why? Because you can read them off here. So I kind of pointed to what each of them are, and you read them off. So to find the sine and cosine, they're pretty straightforward. The thing is the tangent. That's the difficult part. So I'm going to go ahead and finish this off. We're almost there. Just bear with me like 1 or 2 minutes, and we'll finish this off. So for the first one, we're going to have here the tangent of 0. So here will be the tangent of 0 degrees. And then we'll have that equal, okay, to the sine. So we'll use this definition for the tangent of theta, okay? And then we're going to have here, so the sine of 0 degrees over the cosine of 0 degrees. And we have that here, so we can substitute. So that's going to be, for sine of 0 degrees, 0 over 1. So then we have that. Of course, 0 divided by 1, that's just going to be big 0. And there you go. This tangent of 0 is 0. So that's how you would find that. That's how you would write that. So we go to the next one. This one's going to require some division. So we say we can set it up right away though. We can say the tangent of 30 degrees is going to equal the the sine of 30 over the cosine of 30. Okay? So for this one, we can split this up into this. We can split this up into actually the sine of 30 degrees over 1 multiplied by 1 over the cosine of 30 degrees. Now, the sine of 30 degrees, we can find it no problem here. But then this one right here, that's just going to be the reciprocal of that, right? So if we put this 1 over, this is just going to flip this. So if we want to rewrite this, we would say this. We would say this equals to 1/2 multiplied by the reciprocal of that. So 2 over the radical 3, 2 over radical 3, and then this crosses 1, this crosses to 1 because 2, 1, 2 on the top. So let's just actually write it here, and then you'll see how it crosses. 2 over square root of 3, and then that crosses 1, 1. So you get 1 over square root of 3 as your answer for that one. Okay. So then we have here that as the answer for the tangent of 30. Okay, next we have this one, 45, and this one's a pretty straightforward one. You'll see why. It's going to be, you get the setup. So the tangent of 45 degrees equals the sine of 45 degrees over the cosine of 45 degrees. So that's just going to be the square root of 2 over 2 over the square root of 2 over 2, right? Now, the same thing over the same thing. You should kind of recognize this for anything. Of course, anything divided by itself, that would just be 1. So the tangent of 45 is 1. So just see here how you're calculating tangent. You're doing a division of sine theta over cosine theta. Okay, last one. Now here, I want to show you another way to do the division so that you're clear. You can always use this, but I want to show you another way, and we're almost done. So just bear with me. We're super almost done. So this one, then you say the tangent of 60 degrees equals the sine of 60 degrees over the cosine of 60 degrees. Okay, so that's going to be the square root of 3 over 2 over 1.5. Okay, now I want you to rewrite this as this. Okay, remember your rules of fractions. So you're gonna actually rewrite this with the division sign. Sorry, so this is the division sign here. So that's square root of 3 divided by 1/2. Now this goes back to our fraction rules where we actually keep the first one and you multiply by the reciprocal, right? So that's going to be, okay, sorry, the reciprocal is 2/1. Sorry about that. So 2/1. Sorry, 2/1. Okay, so 2/1. And then we're going to have here 2 times the square root of 3/2. The 2's cancel, so the square root of 3 would be your answer for that one. Okay, and then the last one, super quick, so we can be done with this. This is the tangent of 90 degrees equals the sine of 90. And you'll see why you'll get a little undefined here. Over the cosine of 90 degrees, that's going to be 1/0. And then, of course, anything divided by 0 is undefined, and there you go. Okay, that is the end. Thank you.